Good morning, everyone. My name is Harsha Reddy, and today we're going to talk about Presto ETLs at Uber. I'm going to start off with the mission statement. Uber's mission is to ignite opportunity by setting the world in motion. We operate in more than 10,000 cities. We have more than 100 million active users, and we do about 18 million trips a day. Data informs every decision at Uber. Let it be community operations, marketplace pricing, eats, compliance, growth marketing, or data science. Let's look at Presto scale at Uber. We have around 12,000 monthly active users who run about 400,000 queries per day and operate on more than 35 petabytes of data every day. And now a glimpse into the footprint. We have 2 data centers with 3,000 nodes spread across 12 clusters. In this section, I'm going to do a deep dive into the Presto ecosystem, which is the ecosystem with the microservices and the infrastructure components for ETLs. We have 2 types of deployments. One is Neutrino, and the other one is Photon. Neutrino is Presto for real-time analytics. The storage for Neutrino is Pino, and the other one is Photon. Photon is Presto for interactive and batch analytics, and the storage for Photon is predominantly HDFS. We have orchestration system, which is Odin, which does the cluster orchestration for Photon. Data Central is our admin console, wherein we get a bird's eye view of our entire fleet. So if you look at these tabs, each of them represent a cluster: interactive clusters, batch clusters, and custom clusters. And some of this information is masked. It is intentionally masked. But if you see, we have the state of the cluster, like the running queries, the queued queries, the active workers and drivers, and so on. And once we click into one of these clusters, it takes us into a customized coordinated UI, which gives us the queries, the actual queries that are running, who's running those queries, and what the resource utilization looks like for those queries, like the memory, CPU utilization, and what the source from where they're coming, and so on. Prism is gateway to Presto at Uber. To rephrase that better, it is the only gateway to Presto at Uber. What that means is we don't encourage Presto CLI access, JDBC access, or any other means of access. Prism does query routing, which is routing queries to different clusters based on specific rules. It does load balancing, like the concurrency management, so that none of our clusters are overburdened. It does query gating, which is like blocking bad users who can potentially bring down the cluster, or bad queries, which can have like impact on our cluster resources. UWork is our ETL orchestration platform. It is based on an open source project called Streamline. So UWork is basically a UI-based self-service platform where users can come in and author, deploy, and monitor their workflows. It's not just Presto, it even serves like every other engine at Uber. Modulator is Presto's infra management and automation service. One quick point here is more than half of the company uses Presto on a daily basis to do their job. So what that means is if we have a bad deployment, there is going to be a significant business impact. So there's a need for doing a sophisticated amount of testing before we do any change. And at the same time, not compromise on the velocity of our deployments, because the changes in anywhere in our ecosystem, let it be Presto or our microservices, could impact the Presto status or health. So we do shadow tests with Modulator. We do verification and integration tests, which are 2 different types of tests: integration with the other microservices and Presto, And verification test is like an alternative, a customized alternative to the open source Presto verifier. We also have infra management and automations in Modulator, which are like doing rolling cluster restarts, doing automated cluster deployments, identifying slow workers, and all those kinds of things. In this section, I'm going to give a high-level overview of the ETLs at Uber and how it's been going on the last couple of months. Why do we need to do ETL with Presto in the first place? It's a common question that comes up, and one key reason is that we can unify all SQL. So today we already do real-time analytics, we do batch and interactive analytics with Presto. And for ETL, users go ahead and they use a different type of SQL. We could avoid that. It could add a lot of convenience. And more importantly, it results in faster development lifecycle, because the P90 latencies for Presto are much lower than Hive, and it results in a faster run debug cycle. When I say ETL, it's a pretty broad term. So when you say ETL, I'm talking about the self-serve tools that we provide for creating, setting up the pipelines, for the schema evolution, supporting backfills, and we support only those queries that fit in memory. And we have full support, feature support for security and compliance related initiatives. So basically, when users come to UWork, they just select a custom template for Presto, and most of the information with the recommended properties, the session properties are already pre-filled. The user just needs to change their queries and set that ETL pipeline. So when I say faster development lifecycle, what happens today is users start at Presto, they do their analytics in Presto first, and after a point, they decide that it's something that they want to materialize. They convert their Presto SQL into Hive SQL. They go back to Hive, in V-line, they do their testing, and then they go back to ETL orchestration workflow system and ingest and start the ingestion. And then once the data is ingested and materialized, they can come back to Presto to use the same table, right? They can come back there. So what we are proposing, what we're doing right now, is that it's pretty simple, just eliminating Hive from the picture. We just do analytics and ETL using Presto, and they directly configure their pipelines using the orchestration system, and they don't need to go to Hive for any case. So in this new workflow, it's going to result in an improved developer velocity. But this particular model is suitable only for some use cases. It's not going to be suitable for every use case where we can eliminate Hive or batch processing systems as such. So one of those use cases where it can be replaced is this one-click ETL workflow, which is an ideal workflow that we're trying to come up with. Today, what happens is analytics users in the production environment, that is the top half of this diagram, analytics users come to Query Builder, which is like an interface to run SQL. They run their queries, and at a point they decide to convert it into a pipeline. And then there is an integration from Query Builder to UWork, where they convert their ad hoc analysis to ETL pipelines, and they set up a custom pipeline in UWork. But this one-click ETL workflow proposal is that they don't even need to copy-paste the queries into UWork or set up any pipelines. Rather, they just select an option in the user interface layer to say that they just want a pipeline and just provide the URL, the query URL. And the rest of the boilerplate code like inserts, creates, partition, and all those kinds of statements are added by us based on some rules. And they get a pipeline and the output table generated for them. This adds a lot of convenience to the users and definitely improves their productivity to a great extent. And it also improves Presto because once the data sets are materialized, the cost to run queries on the materialized data set is much lower than running it on the raw data sets. You see that Prism redirects cluster like queries appropriately, and here's a glimpse of our non-production environment where Modulator is replaying traffic from production onto staging or different clusters by using a Kafka consumer, which listens to all the queries that are running on our production clusters. So the kinds of use cases that we're doing for Presto ETL are the one-click ETL kinds of use cases. Today, it's not there yet, but people are doing some copy pasting into UWork, and then the pipeline. It's also self-serve where they're able to create their pipelines, but we're trying to eliminate even that part. And the business pipelines is the usual use case, wherein the data engineering pipelines for specific business needs are being created directly in the ingestion system. We want to replace legacy system-related ETLs, like doing some Google Sheet extracts and doing Vertica ETLs with Presto ETL, wherever it can be applied. Data sampling is like a project where we want to create 1% sampled data sets without actually having the need to run analytics on a huge data set. Users could run analytics on this sampled version. The next use case is when users want to load data from HDFS to Pinot. What happens is users write a Presto SQL query. It gets written as an Avro file, and from Avro, the Pinot load takes off. The last use case is our favorite, where it's a platform-driven use cases. Like there are some users who try to stream these large result sets, or who run long-running ad hoc queries with a huge partition range and so on, right? Which are essentially which queries are supposed to be ETL queries, but are being run as ad hoc queries, taking up too many resources. So we are pushing those queries to be materialized. We did a launch last July, and the adoption has been phenomenal. So our users went from around 200 to more than 700 in just 2 months. So there's like a very good demand for Presto ETL right now, and users want to get that convenience factor added into their daily jobs. The current state of ETL is that we run around 250,000 queries per week. We have around 700 ETL pipelines, which includes all those use cases that we discussed earlier. The user adoption is more than 300% just in beta phase. And we have about 280 Presto Parquet pipelines, which is like the Parquet Writes itself. Not everything there is doing Parquet Write in the overall ETLs. It's doing Avro writes, it's doing writes into extracts and so on. So the Parquet Writes leads us to our next topic, which is Parquet, right? So Parquet is widely used at Uber. It is a columnar storage format. It's pretty good with nested data types. It's got very good support for it. The data is stored as row groups, which are like horizontal partitions of rows. Inside these row groups, there are column chunks for each of the column in the data set. And the column chunks are further divided into pages. So for Parquet Writers, we have like 2 writers at the moment. One is the Parquet Record Writer, which is the default option. And the other one is the native Parquet Writer, which was recently released in open source community, and credits to the author of the pull request. Native Parquet Writer is definitely faster and it's better. But Parquet Record Writer also has full feature support. It works as expected. It's just that it's not resource efficient. So for Parquet Record Writer, what it tries to do is the default option. What it tries to do is it tries to convert the data types to Hive types and tries to write like a Parquet Hive record. However, the native writer, what it does is it tries to write the Parquet structures from memory directly onto the file. So we naturally did a comparison of both these writers to see which one works better. And in this benchmark, on the left side, you can see different types of compressions. And on top, we have different types of different data types. So if you see on the left side of the spectrum, the blue indicates the new writer, and gray is the old writer. So the new writer, the native writer, performs better for certain data types and certain types of compression. But if you look at the right side of the spectrum, the performance is pretty comparable. They both behave exactly the same. So this benchmark wasn't conclusive for us to go ahead and put native writer into production. So we went ahead and did some more verification and pre-launch tests. And what it looks like is the native writer results in more than 29% improvement in average CPU time and 32% improvement in query latency. So it's definitely a huge win for us to use the native writer, but we haven't put this into production yet because we're working through some teething issues with the new writer. Let's say like something like compatibility issues with the reader, like issues with data corruption, which is something we're trying to reproduce, and like performance tests in general to see if we can do some level of like a test summary before we just launch it. The next topic is Parquet Encryption. So this is very important because the writer needs to encrypt the data and the reader needs to decrypt the data. So when I say encryption, it is encrypting the data at rest. We do column level access control based on tagging. What it means is tagging is nothing but the level of sensitivity of PII data, whether it's an SSN or like a location or so on. And based on our benchmarks, what we see is that there is a very low encryption and decryption overhead. For encryption, the overhead is around 7 to 8%, and for decryption, it's around 3 to 4%. One thing is we don't encrypt and decrypt all columns. They're only the PII columns or the sensitive columns that need to be encrypted. It's a column level access control. So on the right side, you could see that I'll walk through the legend so that you guys can follow along what happens in the write path and in the read path. So EK is the encryption key that is used for encrypting the data. MK is the master key that is used for encrypting the encryption key. And EEK is the encrypted encryption key that's produced after doing that encryption. So in the write path, what happens is a plain text encryption key is generated. That is passed to Ranger KMS, which is the key management service. The encryption key along with the master key metadata is passed. When I say master key metadata, is nothing but the master key name or the identifier of the master key. No, it's not the key itself. Ranger KMS has the actual master key. So based on the identifier it gets and the key that it gets, it encrypts the encryption key with the master key, generates an encrypted encryption key, and sends it back to the application. And this encrypted encryption key is stored along with the data in the file. Now, when read happens, the encrypted encryption key is already there in the file. So it's sent to Ranger KMS, and using the master key, it decrypts the key and sends it back to the application with a plain text encryption key, which it uses to decrypt and read the data. So credits to the encryption contribution in open source here. In this section, I'm just going to give a glimpse of the ongoing initiatives, all the cool initiatives that the team is working on. The first one is data sampling. As I briefly covered earlier, it's like creating sample version of data sets. But the cool fact about this is that the users don't need to know what the sample table name is. They just have to check a checkbox saying that I want to analyze sampled versions, right? And we do the replacement of the sample table, the actual table with the sample table, so that their analytics happen like much faster, right? If they want to query a much bigger table, instead of running it on a sample table, their analytics time would take like probably more than 20-30 minutes. With sampling, it would come down to about a minute. We're working on Parquet reader optimizations, which is to reduce the overall P90 latencies of our reads. We're working on a Presto connector for Google Studio. This is to replace those kinds of Tableau kinds of cases and BI kinds of cases where we could use Google Studio for BI. We're doing Presto on Flink. So we already do real-time analytics, batch analytics, now ETL. But for ingestion and for streaming, we use a different type of SQL. Presto on Flink is going to address that so that we can use Presto for that as well. Then we're working on Presto on Spark. So there are only certain types of queries that Presto ETL today supports, which fit in memory and so on. The long-running kinds of ETL jobs, which is typical characteristic of ETLs, are something that we don't support in Presto, like queries that run more than an hour or so. So that's where Presto on Spark comes in. So in this kind of deployment, Presto becomes a library which runs in Spark environment. And it is going to handle all those long tail kinds of queries which we don't support today. The next initiative is to Dockerize Presto and set up an orchestration system so that we intelligently orchestrate it with minimal manual effort. The last one is we're doing pattern-based query gating. Today, gating happens based on users and to an extent based on queries. But the pattern-based gating is so cool that when we see a similar query which can potentially bring down the cluster, we block it before it even runs on the cluster. So those are the cool initiatives that are going on right now. I'm really glad to have this opportunity to present today. Thanks a lot. I'm open for any questions.
Wow, that was some dense material. Very, very good stuff. Thank you so much, Harsha. When you talk about the pattern-based query gating, can you go into some detail on that real quick?
So what we're trying to all right, is it better now? Okay, so what we're trying to do is we're trying to come up with okay. Again, okay.
Turn off your own.
Yeah. So, so what we're trying to do is trying to come up with like coming up with signatures for each queries so that we have a pattern identified. And this is like abstracting all those values that come in a query and having certain rules as well. So when we see a similar query that comes in, let's say some bad kind of a pattern with the signature, the same thing comes in again in future, we try to block it. And there are certain rules as well, which again come into like augment the pattern-based blocking.
We always have to worry about bad actors out there these days at scale, right?
Yeah, that's always the case, right? One bad actor can bring down like the cluster and cause like a lot of problems. So yeah, we're doing a lot of things on that front.
Thank you so much for revolutionizing transportation. It's a different world now. I mean, you guys really changed the game in so many different ways, and it's the speed of the platform that really makes it all work, right?
Yes, definitely. I think we feel so proud to be able to make changes to the way transportation works.
That you can see where your driver is coming from, that really changed the game and really changed expectations for people about what level of service they should be getting. And frankly, the taxi companies everywhere really had to innovate, and some of them have, but most of them have not. But this is a classic case where a data foundation, a fast data foundation, can fundamentally change a service, bring better pricing, bring better service across the board, right?
Definitely. Convenience, to a sense, drives innovation. So I think things have become so convenient with Uber that the entire industry, right, going along and